That's me. I'm the founder and CEO at a company called Bauplan. And I'm going to be talking about mostly data infrastructure today and the intersection between that and AI agents and how I think things are evolving pretty quickly in that space. It's a little behind compared to software engineering, but at this point it's pretty clear that a lot of the infrastructure we've been used to needs to be rebuilt for an era where agents will be users as much as people. Basically, what I want to say is that when it comes to, I think software engineering, there's a lot of what we do today with agents that matured a lot in the past 12 months. We started out, with vibe coding, a year ago approximately, where we're kind of helping people that cannot really code well to code well. And now we're kind of have agents in production that became much better, and we're starting thinking about what is a system in production that runs different agents, how I trust the systems in production. Which, when it comes to code, a lot of what happens is that your system is able, your agentic system piggybacks on an existing workflow that is pretty understood and is observable and happens in a very contained loop, which is one of the reasons why this is the main reason, really, why something like Claude Code or your agent works very well. So basically, you read code, it reads code, it generates code, and it runs it and revises it and learns from that. And it's very clear what happens. Your files are local. Your execution happens in the terminal. Things can go back into the context, and we have Git. So we have the guarantees that whatever we do is something we can roll back from, that we have branches and isolation, we can keep track of changes. Now, when it comes to agents that are actually able to do things in production, one important missing point right now is that you ideally want the agent to be able to write and read from data, right? But your analogy kind of breaks down a little bit. Even if you do something very simple, I'm sure how many folks in this room ended up doing at least once a backfill on a table. Even something like that, if we ask Claude to do something like, hey, why don't you add a session duration column to a table that I already have, a number of questions are not exactly clear on how to do that. First of all, is isolation. We're asking the agent to change a table. The table is usually something that other systems depend on. So how do we do it safely? What about atomicity? There's workflows that we ask agents to perform are typically multi-step and complex. Do we have an easy way to understand if the agent drops the ball halfway through? I know there's folks, I don't know if he's in this room, but Adam from Theory of Interest has been kind of thinking more or less systematically about what transactions mean in a world where you have multi-step processes all the time. Observability, this agent now is calling a data warehouse or some processing system in the cloud that processes the data. Do we have a simple way to get everything back into the context so that the agent can reason about it? Or do we have to go fish into the logs and understand several different APIs scattered across different places? And can we roll back? Because ultimately we can kind of destroy a bunch of stuff that we kind of need, like our production data. But the bottom line is that I think what is hard to map, to wrap our head around now with agents in the work of touching data is because unlike code, agent data is non-local by default. If you change something, there's a bunch of production systems that depend on what you change. And unfortunately, we do not have Git. We do not have a simple way to isolate, keep track of what happens, and roll back. So we solved this problem specifically. And basically, you should think about what I'm going to show you now as infrastructure that is built to do data work with AI agents in mind as kind of the first class citizen. What happens in practice is that you have the agent running, generating code in your IDE locally, running that code against a cloud executor. And the point is that infrastructure takes care of doing the isolation, the atomicity of your updates, so that you can use the agent to touch stuff in production, but you have an infrastructure that abstracts away all those four problems that I was describing before that otherwise you're left to figure out by yourself. The important piece that we have here is that when agents get into the mix using an infrastructure that is built for them specifically, and we can let them loose to do a lot of work, the behavioral pattern is very different from what we're used to. And they just, very much like they do with code, like an agent generates 100 times the code that a person generates, it also runs 100 times the workload that a person does, right? So these are like some of the numbers pulled out of like very early deployments, and they're just like orders of magnitude larger than what people do. So the infrastructure below needs to kind of like be built to accommodate this. And we want the agent to do this as much as we can. We want the agent to do like a lot of stuff. We don't want the infrastructure to create a friction between, like a friction for the adoption of your agentic applications in production. There's two main things you need to do to make sure that your data infra and your cloud infra is adapt to this new behavior and allows agents to go crazy. One is everything should be like Git, because Git is awesome, but we have it only for code. We should have infrastructure and also data Gitable like we have with code. Every operation should run in a separate branch, and code, compute, and data should be versioned and snapshot in a place where the agent is able to find them easily, quickly. The other thing is, whatever you do in the background, you want to expose this ultimately as just a very code-first, API-first interface. I don't know how many of you like have a lot of experience with like large data platforms that run like big data stuff. Like they tend to be historically very console UI based, and a lot of stuff happens in a control plane that is very scattered. So what we have been working on is, assuming that like a lot of people in this room, since it's PyAI, like to write Python, it kind of like try to squeeze your entire data platform in the cloud in just like a Python package, so that you can do like data ops as Python, as in like, do you want to do a transformation? Your pipeline should be just like Python. Do you want to declare like how your data assets are? That should also be Python. But also your DevOps and your infrastructure should be in the same place with the same abstractions. So for instance, like in the script here, you see that you have, like your table is declared purely in your Python script. Your infrastructure is declared in that decorator that is called Bauplan Python. Your outer loop, so what you do with your processing, do you want to have like several processes that happens at the same time, reconcile them, different agents querying the data, and do diffs? That also should be Python, right? So this is kind of like very strange if you're used to stuff like EMR, Databricks, like the kind of like more traditional data platforms. So I'm going to show it to you because like it's usually easier to show than to tell. And also live demos are cool. And also Clerk was down, so this might not work. So we'll see. Okay, so basically what I'm talking about here is you have a very familiar and traditional interface with tables and tabular data in this case. And it very much like looks like a warehouse and so on. So there's nothing particularly strange here. You have your preview of the data, you have your metadata, you have your interface for querying, the usual. But one thing is different. You have like these branches, and these branches right here are branches of tables. So are basically versions of your data lake, very much like Git branches, but with all your data assets. These tend to be zero copy over tabular data. Doesn't matter that much. What matters is that what you do here is that, I don't know, let's see if we have some. Sure. Once you go on another branch, you're different in a different version of your data. And very much like a Git branch, you have a commit history that tells you like everything that happened on your data lake, like every operation that modified the status of your data. And so this provides you a way to keep track of everything that happens on your data lake, but also provides you with a very fast time-traveling device, basically. You click on that and you're kind of like being transported into a different version of your data in the past and so on. So this is very much like kind of like, it's the closest thing you can get to Git when you have like a lot of tables in the cloud in your data platform and so on. Now, once you have these abstractions, now we can go back to our agent and have like a very different interface. I apologize that this is not dark mode, but my understanding from back there is that you cannot read the dark stuff. So yeah. But this is basically what you see. So your platform now will look more like a repository. So let's assume that we ask, like, it's very based on things like this, right? The branches that I showed you, this is things that we can see right away, very much as we do in Git we're switching, like, I don't know, we want to remove some, drop, So everything you see like in a UI, like of course, like has this kind of like code first, terminal first interface. When you have like an AI agent doing something like, let me see. Okay. Let's do the duration, the backfill that we were saying before, right? So create a data pipeline done in this way on this table. I want the pipeline to be 2 nodes. I have like a kind of like a general idea of what I want to do. Now, all the agent needs to know is that we have a bunch of CLI commands that we can use to run compute in the cloud and access our data, and a skill somewhere that tells the agent what makes sense to do given a certain workflow, in this case, building a pipeline. What the agent does in the background now is what the agent always does, which is just like generating code and running in the terminal and get the feedback and get better at it and try again and try again and try again, right? So what you get is like the first thing is, okay, I'm going to switch into this other main, into this other branch that is not main. Your main data branch is basically your production system, is where the tables that other systems depend on live. So we don't want to iterate on that data. We're going to branch the data. So we switch to this other branch, and now we can start doing whatever we do, which is, again, generating code. So the example here, for instance, is now I'm in a different branch. Oh, damn. I was wrong about the dark mode. So wrong. So wrong. Yes. OK. And now it's super small, but at least we can read it. OK. It's generating like a Python script. As I said, like everything is Python. So now your pipeline is going to look like this. These are the columns that I want declaratively present in the script. Now I have like the push down that I do against my data lake. This is a query that happens at scale in the cloud, but it's just a script. And you run this iteratively, as you see here in the terminal. So now it reads like the context it reads the output of the terminal, puts it in the context, and does it again, and does it again, and does it again. And all this happens like in a, yeah. Can I zoom in? I can zoom in, but not a lot. No, I cannot zoom in. But I can probably change this. No, I don't think so. Anyway. No, unfortunately, I cannot really zoom in. Sorry about that. But it doesn't matter that much. Like, I'm going to show you this like in the UI so it's easier. Your agent is able to do like the entire pipeline. So you see like pipeline is running and output is verified. You have this new table. So if we could go back to our, the table is going to be called events with stats, right? We can go back here. We can now search for my new data branch, which is going to be something that we just created. This duration backfill. So I have my table. It's here. I can run a query against it. I don't know. Let's do limit 5. Great, I have a table here. Now, crucially, if I go back into my main branch, which is where other systems, for instance, like my dashboards or my machine learning model are reading, and I run this query again, this is going to fail miserably, right? We can merge this. Merge. Sorry?
You're missing an R, but maybe.
That's going to be fine. Like it's reasonably smart at this point. There you go. Yeah. Which is the whole point. If you put everything into context, your model will actually be able to do a lot of your data engineering and your data work. Well, the problem that you have with cloud systems today is that they're not designed for this workflow. So putting things into context is very hard. And having like infrastructure that isolates the workflow is something that you have to take care of. So if this did its job now, I should have a table now here, which I do. But if I don't like this, well, I can go back, do it again, because I travel back in time, and I just undo what I did. Like the whole point is that the very workflow that you have when you do software engineering can be brought in your cloud infrastructure and data if you have like this kind of assumption that everything should be Gitable and everything is immutable, but nothing is undoable. That's kind of like the general principle that you want to have. So this is pretty much like the system, and this is pretty much the workflow that we have in mind. Yeah. So what we can do is chat about this anytime and be in touch if you want to talk about data infrastructure. That's all I have for you.
What questions? Wait, do I need to turn this on? Hello, hello. What questions do we have for Ciro?
There's one man down there.
Oh. It's for this video. Yep.
Yes.
So, question about turning a database into this Gitable form that you can do this with. Is your main branch tracking production rights of external services that are writing to your databases, or are you taking a snapshot of that at a certain point in time and then iterating there?
What the branch is a snapshot at a certain time, not of one data, like of the entire or a subset of your tables in a data lake mostly. Yeah.
So you'll have hashes for production rights as well when new data lands to the lake.
Yes, correct. Yeah. So you're gonna have like basically a hash that corresponds to anything in your Git history of the data. You're gonna have some branches which very much like in Git are just heads of a chain of commits, of a chain of hashes. Yeah. So you should think of everything you saw as like all the operations: query your data, create a table, import new data, drop a table, like all that will take a hash as an argument potentially, and they get relativized to wherever you are in this kind of like multiverse of data. The important thing is that because we control the runtime, we also guarantee you that your merges are atomic. So when I did like that merge, what happens there is there's multiple tables that get written in a space of your in a branch, so in a hashing space of your Git universe, are just like repointed in one place. And I know for a fact that either it publishes or not, which is very important because like people use, like our customers use like the agents to do complicated things, and the agents will always come back to you saying just like, I got it, but like,
I'm kind of curious around the art of the possible here. Like, what happens when data engineers start really embracing Git semantics? Like, I'm just curious, if you have with customers, like what they've done or how their workflow has changed now that you've sort of brought like version control to the data pipelining work.
I mean, to be fair with you, I think that the embracing of version semantics happens mostly through the agent, actually. Like my customers tend to use to delegate this reasoning to Claude very much. And so the pattern that you see changing, sitting where I sit, which is the infrastructure that runs these jobs and makes sure that all the isolation is guaranteed, is that you have multiple agents working at the same time, doing a lot of works. So if typically, on average, if you have a data engineer that runs 4 to 5 queries to do data exploration, an agent is going to run 50 to 60 queries, right? And it's going to be more thorough because of that. It was going to come back with very good answers and very sophisticated reasoning. But on the compute side, I think it changes a lot. From the usage side, people think in skills. One thing that we could do now, for instance, is just ask, hey, that pipeline was great. I have it in production. Do we want to add some data quality test? All right, so there's a new skill that says this is how you add data quality tests. Once you have that, it runs in production, it breaks. You have another skills that is there. It says well, something breaks, fetch the logs, create a new branch, try to fix it, and come back to me when you're done. So like, it's very much kind of like automation of entire of chunks of their end-to-end workflow. That's what we see. Anybody else?
One last question for Ciro. We're going to give it 40 seconds. I'm good for an uncomfortable silence.
I can stand on.
I spent like 6 years of my life teaching calculus at 8 a.m. So it's like, I know how to deal with a long, there we go. Cool. There we go.
Okay.
So most kinds of data, one of the reasons we don't put them in Git is because they will make our Git repository explode.
This is not a Git repository, in fact.
Or wherever you're
This is a
storing
Git
them.
data lake. This lives in S3. The reason why data, that's a very good point. Data doesn't happen to be in your Git because like it's insanely large. And it's always in the cloud infrastructure, which I think is really kind of like the bottleneck today for AI agents to work. Like the data infrastructure is in the cloud and is different from, very different from what you do locally, right? But your agent runs locally. So this entire design is there to tell you, as far as the agent is concerned, this is just code in a repository, and it's just calling APIs. It's the infrastructure that is in the cloud that does that for you. So this data lives as Parquet files, very large. So we process like very large data sets for our customers in your S3 bucket. But your agent doesn't know. As far as your agent know, this is just like Git CLI for data that just like iterates on. Yeah.
Thank you.
All right, let's thank Ciro again.